Dear students, in our today's class we are going to see the solved examples of our exercise 13b. Now before to start or before to go through the solved examples, okay, I would like to remind you these properties of your parallelograms, okay, squares and rectangles, rhombus, okay, or and isosceles trapeziums. So you can see, okay, so the first of all, okay, even though we have discussed all these properties before, but I'm trying to just remind you, okay, and then we'll go through the these solved examples. Okay, first the properties of a rectangle. Okay, if we see the properties of a rectangle, okay, it holds all the properties of a parallelogram. Okay, you can see here a rectangle being a parallelogram. That means first of all a rectangle is a parallelogram. That means all the properties of a rectangle, all the properties of a parallelogram are held by the rectangles, and other than the properties of your parallelogram, this rectangle has two properties. You should remember these properties, okay, because we are going to use these properties in our this example sections. So all the angles of a rectangle are right angles. That means you should remember, in a rectangle all the angles are of your 90 degree. Okay, in a rectangle we have four angles are there, and all the angles are of your 90 degree. The second is the diagonals of the rectangle are always equal. You should remember this one. Okay, the first property is all the angles are your 90 degree, and the second property is the diagonals of the rectangle are always equal. That means you can see here, this is a rectangle, here AC is always equal to BD. Okay, clear? Now next we'll see the, so next we have here diagonal properties of a rhombus. Okay, so rhombus is also a type of parallelogram. It also holds all the properties of a parallelogram, and other than this it has own properties. This properties is okay, opposite angles of a rhombus are equal. Okay, you should remember this one, opposite angles of a rhombus are equal, and diagonals of a rhombus bisect each other. Okay, diagonals of a rhombus bisect each other, and your diagonals of a rectangle also bisect each other. Okay, again you can see here the property again there, the diagonal of a rhombus bisect each other at right angles. Okay, the diagonal of a rhombus bisect each other, but it bisects at a right angle. That means angle formed here, this is your always 90, this is also 90. Okay, so all these 1 2 3 4 angles are here, all four angles are of what, your 90 degree. Okay, and again one more property is here, the property is okay, the diagonals of a rhombus bisect the interior angles. That means you can see here, this AC is the diagonal, this angle is divided into two parts by this diagonal AC, and these two are always equal. Okay, so you should remember all these things. Okay, clear? Then next we'll see, okay, properties of a square. Okay, now properties of a square. So square is also a type of parallelogram. It also holds all the properties of a parallelogram. So other than the properties of a parallelogram, it has its own property. So the properties are like this. You can see here, the first property is all the sides of a square are equal. This is much important. The second, the diagonal of a square are equal. Okay, see, the diagonal of a square are equal and bisect each other at right angles. That means like a rhombus, it also bisect each other at right angles. Okay, the angle which diagonal makes with a side of a square is 45 degree. Means because in your square all angles are of your 90 degree. Now if 90 is divided equally, that means one will be 45. It is understood? Okay, then we have a next here, that is your properties of isosceles trapezium. So you can see here, this is our isosceles trapezium. So we'll see the properties here. Okay, the property is the co-interior angles x, u, y, z are supplementary. That means the co-interior angles means you can see here. Okay, the co-interior angles here, x and u are the co-interior angles, x and y are the x and u are the co-interior angles, and y and z are co-interior angles. Okay, so sum of these co-interior angles are always how much? It is your 180 degree, or you can say the supplementary. Okay, so you can see here, So angle A plus D equal to 180 degree and angle B plus C equal to 180 degree. Again, angle A is equal to angle B. That means these adjacent angles are equal. Okay, you can see here angle A is equal to angle B. In the same way, you can see here that your angle D is equal to angle C. So these are the properties of your what isosceles trapezium. Now we can start our this example section. So you can see here, okay, so this is our first example I have solved here. So first of all, I'll read it out the question. The question is your ABCD is a rectangle with BAC equal to 28 degree. Here ABCD is a rectangle, it is given to us, and again one more thing is given here, that angle BAC is your 20 degree and we are asked to find out your angle DBC. That means DBC, we need to find out this angle. Now see, they have solved in a different way, so I have solved in a little different way. Okay, so it will be easier for you to understand. Okay, now see here, first of all, we know AC equal to BD. That means your AC equal to BD. The reason is that the diagonals of a rectangle are equal. So just I have shown you there. Okay, so diagonals are equal. Now as diagonals are equal and I have multiplied both side half, because AC equal to BD, this is an equation, so you can multiply by half. Now half of AC. Okay, again we have studied one more thing. Okay, the diagonal of a rectangle bisect each other. So bisect means it should be equally divided. Equally divided means you should remember the magnitude of OA is always equal to OC and the magnitude of OB is always equal to OD. So half of AC I have wrote here what your OA. Okay, so you can ask me here why I am not writing OC, because because we are asked to find out this one and one angle is given here, so definitely we need to take the help of this triangle, so I have considered this OA. Okay, in the same way for this BD also, OB will be half of what your half of BD, so you write here OB. So the reason is written here. Okay, now we'll consider this triangle OAB. So just I have said that why we need to consider this triangle. Again, now in this triangle we got, see here, OA equal to OB. This OA and OB are this side of your triangle OAB. So when OA equal to OB, when in any triangle two sides are equal, that means we can say OAB is an isosceles triangle. Okay, now when isosceles triangle, that means what we can write, angles opposite to the equal sides are always equal. That means as these two sides are equal, then if it is 28 degree, then it must be your how much? It must be your 20 degree. Okay, so we got how much? Your OAB and OB are how much? That is your 28 degree. Now again we know, okay, in a rectangle each angle is of your 90 degree. That means angle A is your 90 degree, angle B is 90 degree, angle C is 90 degree, and angle D is also 90 degree. Now see, in this whole angle, okay, this whole angle is how much? This whole angle is your 90 degree. Okay, so we are asked to find out this part. Okay, and this angle is given to us. So see here, we know angle ABC is equal to 90 degree. The reason is angle of a rectangle. Now see, this ABC is actually divided into two parts by this diagonal. Okay, so one is will be your what? One will be your OBA, this angle, and another will be your what? DBC. That means if I combine your, that is OBA and DBC together, then I will get this whole angle, isn't it? So now in place of ABC I can write OBA plus DBC. Okay, now again see, OBA is already given, it is your 28 degree. You can see from here OBA is already how much? It is your 28 degree. Okay, so you write here OBA equal to how much? So now I have transposed this OBA to the right hand side, then the sign will get changed, it will be your minus, then this is your 90 degree. OBA is already it is mentioned, it is your 28 degree. Now your 90 minus 28, that is your 62 degree. So this is our answer to the your example number 1. See, even though it seems like it is longer, okay, and might be you feel might that it's a complex, but it's very easy once you understand the basics, and you can write it by yourself and you can solve it by yourself. Okay, the way I have written, it's not necessary you can write in that way. Okay, you can write in your own way. Okay, but you cannot change these points. Okay, so this is our first example. Now we'll proceed for our second example. Okay, and one more thing I want to add here. Okay, you just don't get panic. Okay, this exercise is very easy, just you need to put some concentration. Once you have understood all the things, okay, everything will be easy for you. Okay, now I'm going to explain this example number 2. And the example number 2 is your ABCD is a rhombus. Now when they are saying ABCD is a rhombus, okay, you must know all the properties of a rhombus. Okay, so we can apply any property here. Okay, then see, ABC is given how much? This is your ABC, this whole is your given 126 degree. Okay, now don't get confused by this 126 is written that side. No, actually you can see this whole is covered here now, which means this whole B angle is your 126 degree. Then we are asked to find out ACD. That means we are asked to find out this angle. Okay, now whenever they are asking this question, okay, you must remember the properties of what your this rhombus. Okay, so first of all, what we know is that, okay, now see, now how to start. Okay, is, see, this symbol means what? This symbol means this is your 90 degree. We are asked to find out this angle. Now somehow if I get the value of this angle, then with the help of this OCD triangle I can find out. Okay, so this is our first step. It's very simple. You can see here. Okay, this one angle is your 126 degree. Okay, and we are asked to find out this, and one angle is 90 degrees. So from there I should be aware that, okay, that means one is given. Somehow if I got the value to this angle, then by applying angle sum property on over this triangle, easily I can find out this angle. Okay, so this is how you have to assume. Now see here, ABC equal to ADC. This ABC is equal to ADC. The reason is the opposite angles of a rhombus are always equal. Okay, that means ADC is how much? ADC is 126 degree. Okay, again rhombus, okay, the diagonals of a rhombus bisect the interior angles. That means if this whole D is your how much? If this whole D is your 126 degree, then this part will be what, your half of 126 degree, and this will be also what, your half of 126 degree. So that's why, now see, here we have a two part, ODA and ODC. But to find out this angle, which one you need? You need ODA or ODC. So definitely you need ODC. So I'll write ODC. So half of ADC equal, sorry, ODC equal to half of ADC. Okay, now ADC means how much? 126. You write here, that is your 63 degree. Now it's very simple for me. You see here. Now I will consider this triangle where one angle, this symbol means 90 degree. This is not known to us, and I got this is how much? 63 degree. Now in any triangle I know two angles. Now easily I can find out the third angle by applying the angle sum property. So now see, if I add all these three angles together here, OCD, this is the first angle. We need to find out ODC, this is the angle, another angle, and again DOC, this is your third angle. Okay, this is your angle sum property on a triangle. Okay, then you see here. Okay, if you want, you can write this one or you can skip this also. Okay, because it is understood that this is already mentioned 90 degree, no need to write here. Now OCD we need to find out. ODC is how much? ODC, that is your 63, you write here. Then your DOC is how much? That is your 90, so you write here. Now okay, you have to transpose this both the angles to the right hand side, then the sign will get changed. Okay, now 60 minus 63 minus 90, it gives me how much? Minus 153. Okay, then 180 minus 153, that is your 27 degree. So our OCD angle is how much? That is your OCD angle is your how much? That is your 27 degree. But we are asked to find out ACD. Now see, you write OCD or the ACD, ultimately you are talking about this angle only, it doesn't matter. Okay, so don't get confused. You write OCD or ACD, it is the same thing, you are talking about this angle. So ACD is also how much? ACD is also your 27 degree. Okay, it's very simple. So hope all of you have understood this one. Then now we are proceeding for the your third example. Okay, see here. Again, one of the diagonals of a rhombus. Now when they are talking about the diagonals of a rhombus, so you must aware of the properties of a diagonals of a rhombus. Okay, is congruent. Congruent means equal to one of its side. Okay, one of the diagonal of a rhombus is congruent to one of its side. Okay, so this one diagonal is equal with any one of side. It is not known to us now. We'll assume this one. Okay, find the angles of the rhombus. That means if your diagonal is congruent with one side, then we are asked to find out what are all the angles of the rhombus. Okay, so very simple. First of all, we have assumed a rhombus ABCD, and they have said that okay, diagonal is congruent with one of its sides. Okay, so you see here BD is the BD is the diagonal, and we have assumed that BD is equal to AB and AD, because in a rhombus all four sides are equal. Now you see here, okay, one of the diagonal of a rhombus is, this is I have read it out. Now BD equal to AB, this is also done. Now see here, ABD is an equilateral triangle. Why it is equilateral triangle? You see here, okay, they have said BD is equal to with one of any one side. That means BD is equal to AB. Again AB is equal to AD. That means all three sides are equal. So now if I consider ABD a triangle, and here all three sides are equal, means what? This is an equilateral triangle. And again we know in an equilateral triangle each angle is your 60 degree. Okay, so you write here 60 degree. Okay, now see, triangle ABD is an equilateral triangle, so BAD equal to 60 degree. That means BAD equal to 60 degree. We know in an equal triangle each angle is your 60. Okay, now see here, okay, but we need to find out all the angles here. Okay, then you can see here, then next you see here, okay, now see, these are the, okay, these are the adjacent angle. Okay, now this adjacent means what? Now see here, AD is parallel to BC in a rhombus. Okay, now see here, if I consider AB as a your transversal, then sum of this angle plus you forget about this 60 degree. Okay, don't get confused from where do we got this 60 degree. Forget about this 60 degrees. Okay, now if I add this plus this, okay, sum of these two is how much? 180 degree. Okay, your co-interior angle, so sum of these two angle is 180 degree. Okay, and again see, one angle is known to me, again your ABD or DBA, that is known to me. This is how much? 60 degree. So you write BAD equal to how much? That is your 60 degree. So 180 minus 60, that is your 120 degree. That means my your ABC, this whole angle is how much? That is your 120 degree. Okay, now this is your 120 degree. Okay, now since the opposite angles of a rhombus are equal, that means if it is 120 degree, it must be your 120 degree. Now if it is your 120 degree, whole is your 120 degree, and we know this BD bisect this angle. Now if I divide 120 into two equal parts, then it will be your 60. This will be also 60, isn't it? Very simple. Now here also, actually no need to consider this one. Now we got this is 120, this is your 120. If this is 60, this must be 60 because opposite angle of rhombus. So this is how we got angle. See here, the first one is 60, this is your 60, opposite is 60, then this is 120, and this is also 120. So these are the values to what your four angles. It's very simple. So hope all of you have understood this one. Now your fourth example is the diagonal of a rhombus are 6 centimeter and 8 centimeter. Okay, now see the two diagonals, because the diagonals of a rhombus are not equal. Okay, so find the length of a side of the rhombus. That means we need to find out the length of the side of the rhombus. Okay, so very simple. See, okay, they have assumed here, actually you could see here ABCD, oh sorry, you can see here ABCD is a rhombus. Okay, where one is your 6 centimeter, another one is what your 8 centimeter. Okay, but what we know, okay, the diagonal bisects each other. Okay, the diagonal bisect each other at right. So your OA will be what, your half of AC, okay, and AC means how much you have, we have assumed this one AC as 8 centimeter, okay, so that is your 4 centimeter. OA is your 4 centimeter. And then you can see here, then BO is also, you can see here BO. Now you might have a confusion, that's why, which triangle to choose here, okay. Very simple here. See, this angle is 90 degree given na? So you should confirm about that. I must have to consider OAB triangle, and in this OAB triangle one angle is 90 degree, that means this is a right angle triangle. That means I must have to apply Pythagoras property here, then I can easily find out that is your AB, okay. So somehow I need to find out the value of this OA and OB, so that's why we have found here OA and OB. So we got the OA and OB, and our angle AOB is your how much, that is your 90 degree. So just I have said, now we'll apply the Pythagoras property. Now I think all of you know the Pythagoras property, but I'll explain it to you for here, for you all here, okay. Now if, okay, if this is a right angle triangle, that means when this is a right angle triangle, when this angle is your 90 degree, I'm naming this one as your ABC, okay. Now you should remember, okay, the angle, okay, the side opposite to this right angle is always hypotenuse. This AC is called what, your, this is called your hypotenuse, okay. This is called your hypotenuse, this is called your base, this is called your perpendicular, okay. I'm writing PRP only. This is called what, your perpendicular. Now according to the Pythagoras property, okay, it is understood that always the square of hypotenuse, for hypotenuse I am writing H, okay, square of hypotenuse is always equal to the square of the sum of other two sides. That means, okay, this will be your perpendicular, so I am writing P square plus this is for base B square, okay. This is what our Pythagoras property, okay. So we'll apply Pythagoras property here also. In this triangle, see OAB, now this angle is 90 degree, that means opposite side is your AB, that means AB must be your what, your hypotenuse. So you write, and what I've said is square of hypotenuse. See here, square of hypotenuse is equal to square of some other two sides. So one is 4, another one is 3, so you square is here 4 square plus 3 square, 4 square 16, 3 square 9, that is your 25. Now square root of your 25 is always how much, it is your 5. Now AB is how much, 5 centimeter. That means all the remaining three sides are also are of what, your 5 centimeter. It's very simple. Hope all of you have understood this one. Now we are going to discuss our example number 5. Okay, it's very simple. Again I am repeating, okay, even though the answers are a little longer, okay, don't get panic, it's very easy. Once you go through by yourself, after understanding the fundamentals, everything is going to be much easier for you, okay. It's very simple. Then see here, example number 5 is your ABCD is a square. Now when they are saying ABCD is a square, you just you know, you should strike in your mind as what are the properties of a square, okay. Then determine DCA, okay, determine DCA, okay. That means I need to determine this angle. So from here only I am sure that if this angle is given 90 degree, that means somehow I have to consider this ACD triangle, okay. Is it clear? Now see, since ABCD is a square, okay, then AD equal to DC, okay. Now see, AD equal to DC. Why? Because in a square all four sides are equal, that means these two are also equal. Now see, if these two are equals, that means what, this is an isosceles triangles, okay. Now see, in triangle ADC, just I have said why we need to consider ADC triangle. So AD equal to DC, when AD equal to DC, that means these two angles must be equal. So just I have said in an isosceles triangles, okay, these opposite angles are always equal. So you write angle 1 equal to angle 2. You just we have just name as 1 2, okay. It's nothing, we have just name as 1 2 for our convenient only to write only. Now if I consider this ADC whole triangle, and if I apply angle sum property here, then 1 plus 2 plus 2, that means your D angle, it will be always equal to how much, 180 degree angle sum property. So 1 plus 2 plus ADC equal to 180 degree, okay. Again just what I have said, angle 2 equal to angle 1. That means any one angle can be replaced by the other angle. So here angle 2 is replaced by angle 1. So this is 1, this 2 is replaced by 1 because 1 equal to 2. This is your 1. Again ADC, this angle is how much? 90 degree. So you write 90 here. Now once you transpose, then see angle 1, angle 1. So this is 1 here, 1 here. That is your 2. 2 times of angle A. Then 90 is transposed this side, then it will be what, your 180 minus 90, it gives me 90. Then 2 is there, it will be go downside, it will go downside. So 90 divides 2, it will be 45. That means our this angle is how much? This is your 45 degree. So hope all of you have understood. It's very simple. Okay, then remaining 2 examples are there, so we'll discuss in our next class. This is what for our today's class. Okay, again I'm saying you just go through the fundamentals. Everything is easy. Okay, you can solve it by yourself. You just have to understand the fundamentals of all the different types of your polygons. Okay, so this is what for the today's class, and thank you very much.